Okay, we're going to look at assignment 22, and we're going to look at problem 75. So you see the picture there. So the picture kind of looks like this, and it shows this little R. It shows the direction that this object is moving, which is important. And then it also shows that it's a certain height above the ground. A ball, so I'm going to write my given. The mass is equal to 0.2 kilograms, and I'm going to chunk it because I want to write down all the important stuff, so I'm going to read it step by step. It's tied to a string and swung in a vertical circle. So the radius is 2 meters. The bottom of the circle is 1.5 meters above the ground. At the top of the swing, the speed is 5 meters per second. So the velocity at the top, I'm going to call it VT, is 5. And at the bottom, the speed is 10. So the velocity at the bottom is 10. So it says A, determine the tension in the top. So what I want to do first is, the key to this is all about my free body diagrams. So for part A, I'm going to draw the free body diagram at the top. So at the top, here's the ball. And the first thing I'm going to say to myself, and this is essential in these problems, is I'm going to say, what is my sign convention? So the centripetal force acts towards the center, so down is going to be positive. Okay. Now I'm going to draw the forces. So I have the tension in the string acting down, and then I also have the weight acting down. So that's my free body diagram with my sign convention. So what I'm going to do is, I'm going to draw my sign convention, and I'm going to say summation of F of C is equal to MAC. So I'm applying Newton's second law. Now I'm going to look at my free body diagram. I'm going to say what forces are acting on this. So I see FT is positive, plus F of G, they're both acting down, which is positive, is equal to MAC. Now I want to find the tension, so I'm going to rearrange the equation and say FT is equal to MAC minus F of G, which is mg. Now I don't know the acceleration at the top, but I know the velocity. So now I'm going to do it one more time and say FT is equal to mvt squared over r, because centripetal acceleration is v squared over r minus mg. So now I'll go ahead and substitute in my values, and I'll have Ft is equal to 0.2 times 5 over 2 meters minus 0.2 times 9.8 meters per second squared. So when I do all this on my calculator, it comes out to be 0.454 newtons. So what you need to do is, you need to, again, draw your free body diagram, establish your sign convention. You're going to be applying Newton's second law. Why is this important? We're on an FRQ. You're going to get a point for this. Then you're going to be substituting in the values, and then all this is like 1 point. So if this was 3 points as part of an FRQ, if you just wrote like this part with the answers, you're only going to get the 1 point, because if you don't show this and this, you miss those other 2 points. So you have to write all this down. All right, now we're going to do we're going to do part B. So for part B, it says determine the tension at the bottom. So at the bottom, again, I have to draw my free body diagram. So over here, now the centripetal force is acting up, so I'm just going to show right here that up is positive. I'm going to draw my tension, And I'm going to draw my weight. And again, these aren't to scale because I'm just using this to help me for my summing forces. So for part B, up is positive. So the first thing I'm going to do is I'm going to write my sign convention. Up is positive. Summation of f of c is equal to MAC. So I'm applying Newton's second law. Now I'm going to look at my free body diagram. Up is positive, tension's up, so FT. Oh, I called it T there. You can call it FT or T. So FT minus F of G is equal to MAC. So now when I rearrange that, I'll get FT is equal to MAC minus plus, because I'm adding it to the other side, F of G. So that's equal to M, the velocity at the bottom, squared over R plus mg. So now when I substitute in my values, 0.2 times 10 meters per second squared over 2 meters plus 0.2 times 9.8 meters per second squared. And when I do all the math, FT comes out to be 12 newtons. So we see the tension is different at the top and the bottom. So we're doing the same steps we did before, but the key is your sign convention. That's the key to these problems. All right, there's only a part C. So part C says the string breaks at the top. So let's look at a picture of this, okay? At the top, the string's going to break here. So that's the velocity at the top. So when it breaks, remember, at this point, the velocity is tangent to the curve at that one point and that one point only. So it's going to look like this, okay? Now, they also gave us this certain height above the ground. So this is going to end up being a projectile like this. Okay, so now we basically have a projectile motion problem. Now, first of all, it's going like this because it's going this way. Now, they told us the radius, so the radius is 2, so this is 4, and then this height is 1.5. So when I write my given, what I'll do is I'll do like I did with projectile motion, because when I take shortcuts, that's how I make mistakes. The horizontal acceleration is 0. G is negative 9.8. We want to be consistent with our sign convention. So because this is all horizontal, V naught x is equal to 5, and V naught y is equal to 0. And then we know y is equal to negative 5.5. Where did I get 5.5 from? It's the 4 plus the 1.5. So where do I start? Well, I have 3 things on this side, and I know the common factor on both sides is t, because t is scalar. So if I find the t here, I would use it here. What if I didn't know to do that? Well, what do I want to find here? I want to find x. Well, I know x is equal to v naught xt, and then plus the 1/2 axt squared, ax is 0. So if I find the time here, I can substitute it in there. So I know g, I know v naught y, I know y, and I want to find t. So I'll say, well, which equation has those 4 variables? Well, that's y is equal to v naught yt plus 1/2 gt squared. V naught y is 0. So y is equal to 1/2 gt squared. I'm going to rearrange the equation to solve for the unknown in terms of the known. So t is equal to the square root of 2y over g. So that's equal to the square root of 2 times negative 5.5 meters over negative 9.8 meters per second squared. So the negative in the numerator cancels with the negative in the denominator, so I don't have a negative under a radical, and the time comes out to be 1.06 seconds. And then once I find the time, I'm going to substitute it back in here. So now I'm going to say x is equal to v naught x, which is 5, times the time, which is 1.06 seconds. So x comes out to be 5.3 meters. So again, it's all about the free body diagrams and the sign convention. If you do that, the whole problem just kind of falls into place. And that's it.